Hello and welcome for our next lesson that we are having. In our previous lesson, we discussed about gradient of a straight line. But in this particular lesson, we shall now consider gradient of a straight line and how it is connected to direct proportion and rates of change problems. To understand the connection between gradient and direct proportion together with the rate of change problems, we shall use the illustration which is on the board. So we want to explore direct proportion using this illustration. So we have water being poured into an empty tank at a constant rate. It takes 3 hours to fill the tank with 6,000 liters. In part A, what is the rate at which water is poured into the tank? So, in that part A, we need to understand that 6,000 liters, that's the volume of water inside that particular tank, took 3 hours for us to have 6,000 liters of water. It therefore means that 3 hours corresponds to 6,000 liters. What about 1 hour? So we established that after 1 hour, the volume of water inside that tank will be obtained by taking 6,000, multiply by 1, then divide by 3. That means we do cross multiplication. After doing cross multiplication, we cancel out those factors which are common. In this case, we cancel out 3. Then we take 6,000 divided by 3, which gives us 2,000. So if we take 2,000 multiply by 1, the result is 2,000 liters. So that means after every 1 hour, 2,000 liters of water will be inside the tank. And that is the rate at which water is poured into the tank. We calculate the amount or the volume of water inside the tank after 1 hour. So we can say the rate is 2,000 liters per hour. So this symbol we have introduced, which is a slash, represents per. So we read this as 2,000, L for liters, this slash is per, H for hour. So we read it as rate is 2,000 liters per hour. Now, we look at our second question, part B. Draw a graph of volume, V in liters, against time, T in hours, using the range of values of T greater than or equal to 0 and less than or equal to 3. Now, class, to draw a graph, there are some basics you need to have. the first basic requirement is for you to have a table of values. In our table, we have two quantities here. We have time in hours, which is represented by letter T. Then we also have a quantity, another quantity V, representing volume in liters. So for us to draw a table, to draw a straight line, we only require 2 points. And that's why we shall only start with the first point of T, which is 0, then have the last point of T, which is 3. So this sign means 0 is inclusive because it is T is greater or equal to 0. And the same T is less or equal to 3. So that means the values 0 and 3 are inclusive. And therefore, we only use those endpoints, 0 and 3 for T. We go ahead and find the corresponding value for volume. So what we do, we go back to our rate in part A. The rate at which water is pouring inside that tank is given as in 1 hour, 2,000 liters of water are poured inside the tank. So we need to calculate what happens when the hours were 0 hours. What about 0 hours? So at 0 hours, the water inside the tank will be 0 liters. So that implies that we don't have water inside the tank in 0 hours. So the value for V is 0. Next, we find the volume of water inside the tank when the value of T is 3 hours. That means after 3 hours, how much in terms of liters, how much volume of water will be inside that particular tank? So we go back to our rate in part A and we said in 1 hour, we have 2,000 liters of water inside the tank. What about 3 hours? So to find the volume of water inside the tank after 3 hours, we take 3, multiply by 2,000, then divide by 1. That means after 3 hours, we shall have 6,000 liters of water inside the tank. And in our table of values, we fill 6,000. Now, using our table values, we can be able to draw that graph, a sketch of it. So the graph must have a title, that is a graph of V in liters, where V represents volume, against time, T in hours. Our graph has y-axis and x-axis. X-axis is independent variable. Y-axis is for plotting dependent variable. In our table of values, the independent variable is time. And therefore, the dependent variable is volume, because the volume of water inside the tank depends on the time. So our first value, our first point is 0, 0. So we plot that point at the origin. The second point is 3, 6,000. Now, having plotted the 2 points, you now take a ruler and join the 2 points. So our endpoints are the origin 0, 0 and the point 3, 6,000. So we have done the graphing. We move now on to part C, that is Roman 1. Find the gradient of your graph. How do we get the gradient of our graph? Gradient is obtained by taking rise divided by a run. So the run here is always positive because it's the horizontal movement of the point. The distance moved by the points horizontally. Then the rise is the distance moved by the points vertically. In other words, the rise is the change in the y coordinates, and the run is a change in the x coordinates. So what we do to find the gradient successfully, we need to create a right-angled triangle using the 2 points. So we are having a right-angled triangle. What is the rise here? That is the change in the y coordinate. To get the rise, it will be 6,000 minus a 0. Which gives us 6,000. Then, to get a run, we take 3 minus 0, which gives us 3. We substitute in our relation. Because the rise is upwards, we consider that positive. So we assign a positive. The run is always positive. If we simplify 6,000 divided by 3, the result is 2,000. And therefore, our gradient is 2,000. So the gradient of this straight line is 2,000. Next, we now find the rule for V. We need to establish the rule that is connecting the variable V, which is volume, and the variable T, which is time in hours. So from the graph, we notice that the graph is a straight line. And therefore, it means that the quantity V, which is volume, is directly proportional to quantity T, which is time. So if one quantity increases, the other one also increases, then that type of proportion is called direct proportion. And when a graph is drawn, you obtain a straight line. So that simply means that the two quantities or the two variables are directly proportional. So in this case, the constant we are having is the gradient, because it's a straight line. So gradient will be constant. From our knowledge of equation of a straight line, y is equal to mx plus c. M is a constant which represents gradient. C is a constant which represents y-intercept. So that means if the graph is passing through the origin, the y-intercept is 0. So the C part is not there. And therefore, our equation becomes y is equal to mx. Y is the quantity plotted along the y-axis, which is normally the dependent variable. X represents the quantity plotted along the x-axis, which represents independent variable. So in our case, the independent variable x is t, while the dependent variable is v. So where there is y, we substitute with v. M is the gradient, and we have calculated our gradient as 2000. Then x represents a quantity on the x-axis, which is independent variable. In our case, it is t. And this is the final rule connecting v and t. So it is read as v is equivalent to 2000 t. So in this second part, which is the last part of that question, we wish to use our rule, the rule we have developed, to find in part 1, Roman 1, volume after 1.5 hours, and in part 2, time to fill 5,000 liters. Now, what we do to solve the volume after 1.5 liters, we first of all write down the rule connecting volume and time. We have established that volume is equivalent to 2000 T. In Roman 1, what do we know? We know that T is equal to 1.5 liters. In part 1, we know that T is 1.5 liters is given. T is 1.5 hours. That is the time. What is not known is volume. So how do we find that volume? We substitute T is equal to 1.5 hours into the rule that we have developed. So V is equal to 2000 is a constant, multiplied by 1.5 is the time. If you take 2 multiplied by 1.5, the answer is 3. Then multiply by 1,000. So in short, if you take 2000 multiplied by 1.5, the result is 3000. And because the volume we are discussing in this case is in liters, it's very important for us to indicate that that unit, because volume can be measured using different units. So in this case, we shall express our answer as 3000 liters. To solve part 2, that is time to fill 5,000 liters, we again write down our rule. V is equal to 2000 T. In this case, we are given V. V is 5,000 liters. You want to get time. T is unknown. So we now substitute where there is V with 5,000. That means we are having 5,000 is equivalent to 2,000 multiplied by t. Then solve for t. To solve for t, we divide both sides by 2,000. So divide both sides by 2,000. If we divide both sides by 2,000, 2,000 on the right hand side cancels. The zeros cancels on the left hand side, and you are left with 5/2. So our time is 5/2, which can be simplified as time is 2.5 hours or 2.5 hours. Where do we get the unit for time? The unit for time is obtained from the question, because whatever we have been doing, we have been working out time in hours, and the volume was being worked out in liters. Now, we want to look at the second illustration, which can assist us to understand further the connection between gradient, rates of work problems, and connection between direct proportion and also gradient. So in this example 2, or illustration 2, it says this graph shows how far a bike travels over 4 hours. So that means the bike starts at 0 hours up to 4 hours. That is representing the time axis. So we are having time in hours. The question goes further. In part A, state how far the bike has traveled after part 1, 1 hour, part 2, 2 hours, and part 3, 3 hours. So in that particular question, we are supposed to use our graph to determine the distance that has been traveled. In this case, the distance is represented on y-axis, because distance is a dependent variable. So that distance is in kilometers. In part B, write down the speed of the bike. That is, rate of change of distance over time. So in part B, we need to understand the definition of speed as the rate of change of distance over time. So how do you write down the speed? Then part C, we are required to find the gradient of this straight line graph. So we need the knowledge and the formula of determining gradient of a straight line. And lastly, part D, what do you notice about your answers from parts B and C? So in that part D, we are supposed to compare the answer obtained in part B and the answer obtained in part C and conclude whether the two are connected or they are not connected. So we shall be able to make our conclusion once we have done the calculations. We shall do the comparison after having done the calculations. Now, let us start by solving part A. State how far the bike has traveled after 1 hour. So we study the graph. At 0 hours, the distance traveled is 0. That's why the graph is starting at the origin. After 1 hour, the distance traveled is 10 kilometers. So I've indicated using an arrow that at 1 hour, the distance is 10. So after t is equal to 1 hour, the distance traveled is 10. You will only indicate on the graph because we are reading the values from the graph. In Roman 2, we need to find out the distance traveled after 2 hours. So after 2 hours, the distance traveled is 20 as indicated on the graph with an arrow. Finally, we determine or we state the distance traveled by that cyclist after 3 hours. So again, we use our graph. Identify where there is 3 on the time axis. Once you identify where there is 3 on the y-axis, on the x-axis, you use a ruler to draw a dotted line up to the graph, up to your graph. Then you draw a straight line again using the ruler to identify that point on the y-axis. In this case, when the t is 3 hours, the distance traveled has been identified as 30 kilometers. So we are through with the part A. We now move on to part B. To answer part B, that is, write down the speed of the bike, in brackets, the rate of change of distance over time. So we need to have a small table and do that very fast. When time was 1, we identified from the graph the distance is 10 kilometers. When the time was 2 hours, the distance traveled was 20 kilometers. When time was 3 hours, the distance traveled from the graph is 30 kilometers. Now, how do we get speed? We go back to the definition of speed. Speed is obtained by taking distance over time. By definition, speed is the rate of change of distance with the time. And mathematically, we write speed is equivalent to distance over time. We start with the first case. When time was 1 hour, distance was 10. So, 10 over 1. And 10 is in kilometers. 1 is in hours. So from here, we can conclusively say that the speed is 10 kilometers per hour. If we use the first values from the table. Suppose we use the second values from the table. That is when time is 2 hours and distance is 20 kilometers. When you use the second case, distance is 20 and time is 2 hours. That reduces to 20 divided by 2, which is equivalent to 10 hours. No, speed is measured in kilometer per hour in this case because you take 20 divided by 2 is 10 kilometers per hour. In the last case, we want to use the last values from our table. That is, when time is 3 and distance is 30, what is the speed? From our initial formula of speed, we said speed is equivalent to distance divided by time. In our case, the distance is 30 kilometers, while the time is 3 hours. When we simplify 30 divided by 3, the result is 10. Now, because distance is in kilometers, time in hours, the speed will be in kilometers per hour. And that's why we have expressed our answer for speed as 10 kilometers per hour. So you might have noticed that in case 1, the speed is 10 kilometers per hour. Case 2, the same, 10 kilometers per hour. If you use the third value, the speed is still 10 kilometers per hour. So that means that particular bike was moving at a constant speed of 10 kilometers per hour. So the speed is 10 kilometers per hour, which is constant. So the rate of change of distance over time is 10 kilometers per hour. Let us now look at part C. Find the gradient of the graph. How do we get gradient? As we mentioned earlier in our previous lesson, to get the gradient of a straight line, we take the change in y divided by corresponding change in x coordinates. In our case here, we used the term rise over run. Rise here means the vertical change, and the run is the horizontal change. So we pick any 2 points from the line, from the graph that has been drawn. In this case, we can pick the first point, which is 0, and the last point, which is 4 and 40. If we pick those 2 points, we now introduce or create a right-angled triangle. Having created the right-angled triangle, we indicate the rise and we indicate the run. So when we look at our right-angled triangle, the y values are increasing from 0 to 40. That means the rise is positive. Is upward. While the x values are increasing from 0 to 4. So that means the run is also positive. And therefore we shall take 40 minus 0 which gives us 40. So the change in y will be 40 minus 0. Then the change in x components will be 4 minus 0. And therefore, we get 40 divided by 4, and the result is 10. So that means the gradient of our graph is 10. We now finalize by looking at the last part of the question. What do you notice about your answers from parts B and C? Looking at what we have already done in part B, the speed, which is the rate of change of distance with the time, has been obtained as 10 kilometers per hour, and it is a constant. Similarly, in part C, the gradient, which is given by a rise over run, is 10. So that means the two values are equal. So the rate of change of distance with the time is equal to the gradient. And from our graph, the rate of change of distance with the time is direct proportion. The gradient is a constant, and therefore we can conclusively say that the gradient of a straight line is connected to direct proportion. Now, for any straight line, the general equation of a straight line is normally y is equal to mx plus c. But in this case, we can use even another letter like b. M here implies gradient, and b stands for y-intercept. Y is a variable which is normally plotted on the vertical axis. X is a variable which is normally plotted on the what we normally call the independent variable, and is normally plotted on the x-axis. From our graph, the gradient is 20. Sorry, the gradient is 10. The y-intercept, that's where the graph is cutting the y-axis, is 0. So that means our b is 0. And therefore, the rule can be obtained as follows. The quantity that we plotted along the y-axis was distance. So instead of y, we can use distance, d. D to represent distance is equal to m is gradient and is 10. The quantity we plotted along the x-axis is time, which is t. So we shall represent with letter t. And b is the y-intercept, and in our case, because the graph is passing through the origin, the y-intercept is 0. So plus a 0. So in this case, we can simplify and say d is equal to 10t. So this is the rule. The rule or the relation connecting d and t, distance and time, for that particular motion for a bike. Now, we have looked at gradient in this particular lesson. We have also looked at the relationship between that gradient, direct proportion, and the rate of work problems. We have established that the gradient, rate of work problems, and direct proportion are always connected, and the best way to relate the three is by using the general rule y is equal to mx plus b, where y represents the quantity plotted along the y-axis, which is normally the dependable variable, while x represents the quantity plotted along the x-axis, which normally represents independent variable. M is normally a constant which represents gradient, and finally b is a constant which represents y-intercept. Thank you.